If R is this set containing the ordered pair AB such that A plus 5B is 42 and A and B, these two are natural numbers. If this set has M elements and the value of this sum, right, sigma n from 1 to m, 1 minus iota raised to n factorial, if this is x plus iota y, where iota is root over minus 1, then we need to find the value of m plus x plus y. So in this problem, basically we have to find that how many elements are there in this set, how many natural numbers are there a and b such that a plus 5b, this will be 45, and then we need to find this sum, right? So the given relation is that a plus 5b, this must be 42, and a and b, these two are natural numbers. So when you can count, you'll get only few cases here. We can start, because b has a higher coefficient, we can start with b. And if I take any value of b starting from 1, we'll get some value of a. And we have to see that what is the maximum value of b that we can take. A and b are natural numbers. So if I take b as 1, a will be 37. If I take b as 2, a will be 32 and so on. So the different possible values of b will be, you can take 1, 2, 3, 4, 5. If I take 6, then we'll get 30. So A will be 12, then 7, 8. If I take B as 9, then A will become negative. And remember, we have to keep A and B as natural numbers. So the maximum value of B that you can take is 8. If you take B as 8, A will be 2. And if I take a value bigger than 8, if I take 9, 10 and so on, A will become negative. So these are the 8 different possible values of B. And in each case, you'll get some ordered pair AB. So the value of M was the number of elements in this set. So therefore, you can say that M must be 8. Right? Total there will be 8 element or 8 ordered pair AB, where A and B are natural number and A plus B is 42. So M is 8. Now let us find the value of this sum. Let us say that this sum is S. So S is basically sigma 1 minus iota raised to n factorial, and the value of n, this is from 1 to m we have already calculated, this is 8. So this will become sigma 1, which is 8, right? 1 plus 1 plus 1, 8 times. And after that, we'll get iota raised to, in place of n, we have to write 1. So it is 1 factorial, which is 1. Iota raised to 2 factorial, 2 factorial will be 2, so iota square. 3 factorial will be 6. And then we have iota raised to 4 factorial, iota raised to 5 factorial, iota raised to 6 factorial, up to 8 factorial, right? Up to iota raised to 8 factorial. And remember, iota raised to 4, this is 1, right? Iota square is minus 1 and iota raised to 4, this will be 1. So once the exponent of iota is 4 or multiple of 4, the value of that term will be 1, right? So here this sum will become 8 minus, and then this is iota square is minus 1, iota raised to 6, this is also minus 1. And after 4 factorial, all of these numbers are multiple of 4, right? 5 factorial is 5 into 4 factorial, 4 factorial will be 24, 6 factorial is 6 into 5 into 4 factorial and so on. So all of these numbers, they are multiple of 4, and hence the value of each one of these term will be 1. Right, so iota raised to 6, that will be minus 1. Iota raised to 4 factorial will be 1. 5 factorial is also 1. And similarly, 6, 7 and 8 factorial, each one of these terms will be 1. Now you can cancel these two terms. So finally we are getting 8 minus 3, that will be 5 minus iota. So this sum will be 5 minus iota. And it is given that this sum is x plus iota y. So now I think we can write the answer. The value of m was 8, and if I compare with this one, sum s is 5 minus iota, this would be x plus iota y. So x must be 5 and y must be minus 1. So x is 5, y is minus 1, and this will become 12, 13 minus 1, that is 12. So the correct answer for this problem will be first option. This was a basic problem from this property of iota, that iota raised to any multiple of 4 is 1. And also if I have to find number of times in this series, then start with different values of b, because b has coefficient 5. So you will get few cases from there. Once b is a number bigger than 8, a will become negative. So that means there are 8 possible values of b, and corresponding to each value of b, we have some value of a, which is natural number. So in this set, we had 8 elements. And finally, this sum was 5 minus iota. And after adding that, the correct answer for this problem will be 12. If alpha plus iota beta and gamma plus iota delta are the roots of this quadratic equation, where iota is root over minus 1, then we need to find the value of alpha gamma plus beta delta. Now, the general method of solving this problem will be to find the root of this quadratic equation using quadratic formula. And then by comparing the real and imaginary part of those roots, we can find the value of alpha, beta, and gamma and delta. However, there is another interesting approach of solving this problem. But in order to uh, solve using that approach, we have to know one simple concept from quadratic equation. The concept is that if I have a quadratic equation of this form, ax square plus bx plus c equals to 0, and in this quadratic equation, if sum of coefficient is 0, that means if a plus b plus c is 0, then without solving, you can find the root of this quadratic equation. If a plus c, b plus c is 0, that means if sum of coefficient is 0, then one of the root of this quadratic equation will be 1 and the other root will be c by a, because in place of x, if we write 1, it will satisfy. And in any quadratic equation, if the roots are alpha and beta, then product of root alpha into beta, this is c by a. So if one root is 1, the other root will be c by a. And there is another related concept, that is, if I have a minus b plus c equals to 0, then for that quadratic equation, one root will be minus 1 and the other root will be minus c by a. Right? Because now x equals to minus 1 will satisfy this equation. And in any quadratic equation, product of root is always c by a. So if alpha into beta is c by a and alpha is minus 1, beta has to be minus c by a. So this is one very simple concept from quadratic. Now let us rewrite that given equation. The given quadratic equation is x square. Let us take minus sign inside. So then we have 2 iota minus 3 into x. And this minus sign also we can take inside. So 2 minus 2 iota. This is 0. This is the given quadratic equation. And as you can see that in this quadratic equation, sum of coefficient will be a plus b plus c. Now coefficient of x square is 1. Coefficient of x is 2 iota minus 3. And the constant term is 2 minus 2 iota. 3 minus 3 and 2 iota minus 2 iota, those two will cancel. That means in this quadratic equation, sum of coefficient is 0, which means one of the root of this quadratic equation will be 1 and the other root will be c by a. That means constant term divided by coefficient of x square. Coefficient of x square is 1. So that means other root must be 2 minus 2 iota. So without solving this problem, simply by this observation that because sum of coefficient is 0, the root of this quadratic equation must be 1 and c by a. And from there you can easily find the value of alpha, beta, gamma and delta. This root, first root, well, let us say this is alpha plus iota beta, and this second root is gamma plus iota delta. So now you can easily see that if I compare the real and imaginary part of this these two complex numbers, so alpha is 1 and we need to find this one, alpha gamma plus beta delta. So alpha is 1, gamma is 2, beta is 0 because for this root there is no imaginary part, and delta is minus 2. So finally we are getting this number as 2, and hence the correct answer for this problem will be first option. So this was not difficult problem, just one simple observation that sum of coefficient in this quadratic equation is 0, coefficient of x square, coefficient of x, and the constant term, sum of these three is 0. That means one root will be x equals to 1, right? In place of x, if we substitute 1, the left hand side will become 0. So one of the root is 1, and in any quadratic, product of root is always c by a. So if one root is 1, the other root has to be c by a. So directly we got the two roots. And if two complex numbers are equal, the real part as well as imaginary part will be equal. Finally, after Substituting the value of alpha, beta, gamma, and delta, we got the correct answer as 2. Let O be the origin and the point A be represented by this complex number root 3 plus 2 root 2 iota, and point B is representing the complex number Z2 such that root 3 times mod Z2 is same as mod Z1, and argument of Z2, this is argument of Z1 plus pi by 6. Then we have to identify the correct statement about this triangle AOB where O is origin. Now, this is a problem on basic concept of modulus and argument of a complex number. The complex number Z1 is given and point A is representing this complex number. So, A will be nothing but root 3, 2 root 2, x coordinate root 3, y coordinate 2 root 2. And Z2 is another complex number which is satisfying these two conditions. One is for modulus and the other one is related with the argument of complex. Argument of Z2 is argument of Z1 plus pi by 6. So let us plot these points in complex plane and then try to identify which type of triangle we are getting and what is the area of that triangle. So first let us plot this point A representing complex number Z1. Let us say this is some point A presenting Z1. Coordinate of A will be x coordinate root 3 and y coordinate 2 root 2. Also, argument of Z1 will be nothing but angle made by this line OA with x-axis, and modulus of Z1 will be the distance between these 2 points O and A. So clearly you can see that mod Z1 or the length OA, this will be distance of point root 3 to root 2 from origin. So it will be 3 plus another 8, so that will be root over 11. This is our real axis and this one is imaginary axis. So point A is at a distance of root 11 unit from origin. Now Z2 is represented by point B and the relation is that modulus of Z2, this will be modulus of Z1 divided by root 3. So the distance of point B from origin will be root 11 by root 3. And also argument of Z2 is argument of Z1 plus pi by 6. So if this is argument of Z1, let us call this angle as some angle alpha. Then angle made by the line OB, point B is representing Z2 with x-axis, that will be uh, alpha plus pi by 6. That means this angle has to be pi by 6. Right, this angle will be pi by 6. And here we have this point B representing the complex number Z2. And modulus of Z2 is nothing but modulus of Z1 by root 3. Mod Z1 is root 11. So that means this length will be root 11 by 3. Right. Now we are getting this triangle O is origin and we have this triangle AOB. Now there are two problems in this. One, we need to find the area of triangle, and other one we have to find the, when two sides are 11 and root 11 by 3, we need to find the third side, and then we need to check whether it is Asclean triangle or we have isosceles triangle. Right. So first let us calculate area and see whether any option is matching or not. So for finding area of any triangle, the standard formula is half product of any two sides. So one side is OA, another side is OB, and into sine of angle between those two sides. So that means sine pi by 6. This is standard formula for finding area of any triangle. Area of triangle AOB, so half of OA into OB into sine of angle between OA and OB. Now this will become half of, one side is root 11, another one is root 11 by 3, and the angle is 30 degrees, sine 30 will be 1 by 2. So ultimately this will become 11 and that divided by 4 root 3, right? 2 into 2, 4 and root 3. So 11 by 4 root 3, that is the area of triangle. Now as you can see that none of the options are matching. So I mean option A and B area is different. So these two are incorrect option. Now let us find the third side of the triangle and then try to identify that out of these two options C and D, which one is the correct option. So let us say this third side AB is lambda. Now in order to find this third side, we can use cosine formula. So that means cos of pi by 6, right? Cos of this angle will be OA square plus OB square minus AB square, and that divided by twice of OA into OB. OA square means 11, OB square means 11 by 3, and then minus lambda square, right? That is cosine formula, that cos of any angle is sum of square of two adjacent sides minus the opposite side, and this divided by twice of OA into OB, right? OA is root 11 and OB is root over 11 by 3. So using this formula, we can find the value of lambda. Once you simplify this one and do the calculation, you will find that lambda will be root over 11 by 3, right? So that means this third side is root 11 by 3. Now this angle was pi by 6 and these two sides are equal. Side OB is same as side AB. So if two sides are equal, clearly it cannot be a scalene triangle. It has to be isosceles triangle. And also if this angle is pi by 6 and the two sides are equal, this angle is also pi by 6 and here we'll get 2 pi by 3. So it is obtuse angle isosceles triangle, and therefore the correct answer for this problem will be fourth option, right? The right answer for this problem will be option D. So this was not a difficult problem. The important concept was to be familiar with the concept of argument and modulus. Modulus is distance from origin. Argument is the angle made by that uh, point joining origin with the x-axis. So once you plot these 3 points, then after that for area of triangle we have a standard formula, half of product of any two side into sine of angle between those two sides, and using cosine formula we calculated the third side. Finally, the correct answer for this problem is fourth option. Find the least value of mod z, where z is a complex number which satisfies this inequality that e raised to this expression is greater than or equal to log of modulus of this complex number to base root 2. So basically the problem is that we need to solve this inequality and then we have to find what is the least value of mod z that will satisfy this inequality. So let us say that mod z is alpha. Right, in place of mod z, we are going to write alpha. So the given expression is e raised to, and then we have mod z plus 3. So that means we have alpha plus 3, this multiplied by alpha minus 1. And remember, alpha is representing modulus of a complex number, so it cannot be negative, right? Alpha will be a positive number. So in denominator, we have mod z plus 1. Now this number mod z plus 1 is already a positive number. So this another modulus sign is meaningless here. This will become simply alpha plus 1. That will be the denominator part, and this multiplied by log 2 to base e or ln2, and this thing is greater than or equal to log to base root 2 and modulus of this complex number. Now modulus of this complex number will be root over real part square plus imaginary part square. So 25 into 7, 175 plus another 81. So that will make it 256. Square root of 256 will be 16. So this is the right hand side. Now clearly you can see that this number log 16 to base root 2. So I mean this number will become 8, right? 16 is 2 raised to 4. That means root 2 raised to 8. So if I simplify this one, the right hand side will become 4 into 2, that will be 8. So basically this right hand side is nothing but 8. And now we can take log on both sides so that we can get rid of this exponential function. So if I take log on both sides to base e, then we'll get alpha plus 3, alpha minus 1, this multiplied by log 2, log 2 to base e, so that means ln2, and this divided by alpha plus 1, and the right hand side will be log of 8, log 8 to base e. 8 is 2 cubes, so this we can write as 3 into ln2. Now ln2 you can cancel from both sides, and remember alpha is a positive number, so we can do cross multiplication, right? Ideally, in order to solve such type of inequality, take 3 on one side and then we need to solve. But we know that alpha is modulus of this complex number. Alpha is mod z, so alpha cannot be negative. It has to be either positive, and it cannot be 0 also, because I mean here all the options are non-zero options. So we can cross multiply this one, and that means we have alpha plus 3 and this multiplied by alpha minus 1, and this should be greater than equal to 3 alpha plus 1. Because we are multiplying both sides by positive number, the inequality will remain unchanged. And now we need to solve this inequality. So if I simplify, we'll get alpha square 3 minus 2. So that is 2 alpha minus 3, and this is greater than equal to 3 alpha plus 3. So that means we have alpha square minus alpha minus 6 greater than equal to 0. The factors will be alpha minus 3 into alpha plus 2 greater than equal to 0. Now again, this term is a positive term, right? Alpha is a modulus of complex number, so this one is positive. That means alpha minus 3, this should be greater than equal to 0. So from here you can see that alpha must be greater than or equal to 3. So that is the solution that we are getting, right? The solution of this inequality is alpha greater than equal to 3. Now alpha is the modulus of the complex number. So therefore the least value of alpha, this will be 3. And hence the correct answer for this problem will be second option. Right, so this was a very basic problem on solving inequality. First, we had to find the modulus of this complex number. Then, after simplification, the right hand side became 8. Now take log on both sides. And because alpha is positive number, so we can cross multiply after solving. And again, here this term was positive, alpha plus 2. So finally, we got alpha greater than equal to 3. So the least value of modulus of z, that will be 3. And hence the correct answer for this problem is second option. Let A be set of all the values of theta in 0 to 2 pi such that this complex number is purely imaginary. Then we have to find sum of all the elements in set A. So basically we need to find those values of theta for which the given complex number is purely imaginary, and then we need to find sum of those values of theta. Now remember, if we have a complex number of this form x plus iota y, then x is called the real part of the complex number, y is imaginary part of the complex number. And if the imaginary part of this complex number is 0, that means if y is 0, then we say that this complex number is purely real, right? And another possibility is that real part of this complex number is 0. If real part of any complex number is 0, then we say that this complex number is purely imaginary. So in JEE Main, you'll find there are few PYQ on this concept, that some complex number is given using some trigonometric function, and then you have to find the values of theta in some given interval for which that complex number is either purely real or purely imaginary. So if it is purely imaginary, the real part must be 0. And if it is purely real, then imaginary part must be 0. So if this complex number is purely imaginary, the real part of that complex number, that means real part of 1 minus 2 iota sine theta, 1 plus 2 iota sine theta, and this divided by 1 minus iota sine theta, this must be 0. Now, if I have to separate the real and imaginary part of any complex number, then first we need to write that in this standard form x plus iota y. Now, here you can see that in denominator also we have iota. So, we need to get rid of that iota from denominator. And for that, we can multiply and divide by the conjugate of denominator. That means we can multiply with 1 plus iota sine theta, and then we need to divide by the same thing, 1 plus iota sine theta. So this is the given complex number, and we have multiplied and divided by 1 plus iota sine theta, and because it is purely imaginary complex number, the real part must be 0. Now you can very easily see that real part you will get when you multiply 1 with 1 or iota with iota, right? So real part of this complex number will be 1 and then 2 iota square, so minus 2 sine square theta, and in denominator also you'll get something, but because the right hand side is 0, so this will not have any effect, right? 1 plus iota minus iota square will be 1, so 1 plus sine square theta, this equals to 0. So basically this is the equation that we are getting, right? The real part of complex number will be this one, and from here you can see that sine square theta will be 1 by 2, that means sine theta is 1 by root 2 and minus 1 by root 2. Now the question is, what are the different values of theta in 0 to 2 pi? So when this is Very basic. You can directly see that different values of 1 by root 2 you will get in first and second quadrant. One at pi by 4, another one at 3 pi by 4. And similarly, minus 1 by root 2, this you will get in third and fourth quadrant. In third quadrant, 5 pi by 4, and in fourth quadrant, 7 pi by 4. So these are the different values of theta. These are the four different values of theta in 0 to 2 pi, where sine theta will be plus minus 1 by root 2, and the complex number will be purely imaginary. Now, after calculation, this will become 12 plus 4, 16 pi by 4. So that is 4 pi. And hence the correct answer for this problem will be fourth option. Right. So this was not difficult problem, very basic problem. And if it was given that complex number is purely real, then you will equate the imaginary part to 0. Here it is given that it is purely imaginary, that means real part will be 0. Multiply and divide by conjugate of denominator. Finally, we got sine theta as 1 by 2 or minus 1 by 2. These are the four values of theta. Their sum will be 4 pi, and hence correct answer will be fourth option. If alpha and beta are the roots of this quadratic equation in Z, where iota is root over minus 1, then we need to find the value of this expression. 16 into real part of this complex number, alpha raised to 19 plus beta raised to 19 plus alpha raised to 11 plus beta raised to 11, and that divided by alpha raised to 15 plus beta raised to 15. The second term is also same, but here we need imaginary part of that complex number. Here we need real part. Now, for this equation, the roots are alpha and beta. First, we need to simplify this expression, and then we'll see what are the real and imaginary parts of this one. So for a moment, let us say that this complex number is omega, right? This complex number alpha raised to 19 plus beta raised to 19 plus alpha raised to 11 plus beta raised to 11, and that divided by alpha raised to 15 plus beta raised to 15. Let us call this complex number as omega. So we have to think that how we can simplify this one. And remember, alpha is the root of this quadratic. So alpha will satisfy this quadratic equation, right? Now see here what we can do is that in denominator you have alpha raised to 15 plus beta raised to 15. So try to create the same thing in numerator. From these two terms, alpha raised to 19 and alpha raised to 11, you can take alpha raised to 15 common, and that means we have alpha raised to 4 plus 1 by alpha raised to 4. We'll see how to find the value of this one. And similarly, from the remaining two terms, you can take beta raised to 15 common, and that means you have beta raised to 4 plus 1 by beta raised to 4. This will be the numerator part of this complex number omega, and that divided by, in denominator, we have alpha raised to 15 plus beta raised to 15. This is the complex number omega, right? And now, because it is given that alpha is the root of this quadratic equation, so we'll try to find the value of alpha raised to 4 plus 1 by alpha raised to 4. And same thing we can do for beta also. So if alpha is the root of that given quadratic equation, we can say that 2 alpha square minus 3 alpha minus 2 iota, this will be 0. In place of z, we can substitute alpha because alpha is the root of this equation. And now we have to think that how we can create this term alpha raised to 4 plus 1 by alpha raised to 4. So for that, take this 3 alpha on other side. So that means 2 alpha square minus 2 iota. This will be 3 alpha. Now divide everything by alpha and also take 2 common. So then it becomes alpha minus iota by alpha, and this will be 3 by 2. We have divided by alpha on both sides, and we have also, when we have divided everything by 2 alpha, right? So this is what we are getting. And now we can square. The reason we are writing in this form is because if I use a minus b square formula, then in twice ab term, alpha and 1 by alpha, this will cancel. So we'll get alpha square plus 1 by alpha square or minus 1 by alpha square, and then after one more square, we can create this term. So if I square this one, we'll get alpha raised to 4, and then iota square by alpha square. Iota square is minus 1, so minus 1 by alpha square, and then minus twice AB. Now in minus twice AB term, alpha will cancel, and on right hand side we have 9 by 4. So this is what we are getting for alpha square minus 1 by alpha square. Now the same relation you can write as alpha square minus 1 by alpha square. This equals to 9 by 4 plus 2 iota. And we can square one more time to get the value of alpha raised to 4 plus 1 by alpha raised to 4. If I square this one, we'll get alpha raised to 4, 1 by alpha raised to 4 minus 2. And the right hand side will be 81 by 16 minus 4. And then the twice AB term will have 4 will cancel. So I think we'll get 9 iota from here. Right, this will be the twice AB term. 2 into 2 iota into 9 by 4. So finally the value of alpha raised to 4 plus 1 by alpha raised to 4. This will be 81 by 16 minus 2. So 81 minus 32, that will be 49 by 16 plus 9 iota. So this is the value of alpha raised to 4 plus 1 by alpha raised to 4. Now remember, beta is also the root of same equation. So for beta raised to 4 plus 1 by beta raised to 4 also will have the same value. And that means this complex number, now you can write this complex number omega as alpha. I mean, these two will have same value, because when you can replace alpha with beta and then do the same sequence of steps. So beta raised to 4 plus 1 by beta raised to 4, that will also have the same value. So that you can take common. So then we are left with alpha raised to 15 plus beta raised to 15, and this multiplied by 49 by 16 plus 9 iota. Because alpha and beta were the roots of same equation, so there will be same relation in terms of beta also. And this divided by alpha raised to 15 plus beta raised to 15. Now these two terms you can cancel. So ultimately omega is 49 by 16 plus 9 iota. And now the problem is we have to find the value of 16 into real part of this complex number multiplied by imaginary part. So for this problem, the answer will be 16 into real part is 49 by 16 and then imaginary part is 9. Now 49 into 9, so this will be 21 square, which is 441, right? So the correct answer for this problem will be first option. So this was a problem where, I mean, it was important to take alpha raised to 15 and beta raised to 15 common. And then from the given equation, first we need to calculate alpha square minus 1 by alpha square. And then again you have to square that one to create this term alpha raised to 4 plus beta raised to 4. Once we had values of this term, then we calculated omega. Omega was 49 by 16 plus 9 iota. So real part will be 49 by 16, imaginary part will be 9. After calculation, we'll get 441, and hence the correct answer for this problem will be first option. Let Z belonging to C, that means Z is a complex number, be such that it satisfies this equation. Then we have to find the sum of all possible values of Z square. Now here, first let us rewrite this equation and then see what type of equation we are getting, so that from there we can get an idea that what are the different possible values of Z we can get. So here if you cross multiply this one, right, we have Z square plus 3 iota divided by some expression in Z, and this is 2 plus 3 iota. So one can rewrite this equation as Z square plus 3 iota, and this equals to 2 plus 3 iota, and this multiplied by Z minus 2 plus iota. And now you can see that we are getting a quadratic equation in Z, right? We have Z square, on this side we'll get Z, and then we'll have some constant term. So let us try to write this in a standard form, Z square, Z, and then constant equals to 0. So we can rewrite this as Z square plus 3 iota, and this equals to 2 plus 3 iota, this multiplied by Z, and we are going to multiply these two terms to see that what we are getting here, right? So if I multiply these two terms, we'll get minus 4 and then minus 3 iota, so that will be minus 7, and then we have 2 iota minus 6 iota, so that will be minus 4 iota, right? And now if I rearrange, we'll get Z square minus 2 plus 3 iota into Z plus 7 we can take on other side, and 3 iota plus another 4 iota. So 7 plus 7 iota, this equals to 0. So this is the quadratic equation that we are getting. And the question is, we do not need actual value of z, we need sum of all possible values of z square. So clearly this is a quadratic equation in z, that means we'll get two values of z. Now if I needed actual value of z, then you can use quadratic formula, and you'll have to find square root of a complex number, because I mean discriminant you will get root over something complex. Uh, so here we do not need actual value of z, we need sum of all possible values of z. So let us say root of this equations are z1 and z2. So basically the problem is we need value of z1 square plus z2 square. So for this we can use the relation between roots and coefficients of a quadratic equation. z1 square plus z2 square, this you can write as z1 plus z2 square minus twice of z1 into z2. And now in this quadratic equation, sum of roots will be minus b by a. So that means we have 2 plus 3 iota by 1, right? That will be sum of the roots. And product of roots will be c by a. Now c by a will be 7 plus 7 iota. Now if I expand this one, you will get 4 minus 9. So that will be minus 5. And twice ab term will be 12 iota. And then minus 14 iota. This is what we are getting. Now clearly you can see that this will become, if I separate the real and imaginary part, so minus 5 minus 14, so that will be minus 19, and then 12 minus 14, so that will be minus 2 iota. So this is something that we are getting, and clearly this is option B, so that should be the correct answer for this problem, right? So this was a very simple problem, you can say, but you have to be aware of the fact that we do not need the actual value of z, we need sum of all possible values of z. So here, instead of finding the actual root of this quadratic equation, we can say that, let us say roots are z1 and z2. So we can use the relation between roots and coefficients of a quadratic equation, right? Sum of root minus b by a, product of root c by a. So from there we got z1 square plus z2 square as minus 19 minus 2 iota. And therefore the correct answer for this problem will be second option. If alpha is a root of this quadratic equation, x square plus x plus 1 equals to 0, and the value of this sum, alpha raised to k plus 1 by alpha raised to k square of that, where k is from 1 to n, this is 20, then we have to find the value of n. Now clearly you can see that if alpha is a root of this equation, we know that root of this equation is omega, and omega is square, right? If I have this quadratic equation, x square plus x plus 1 equals to 0, so the root of this quadratic equation will be omega and omega square, and where omega is minus 1 plus root 3 iota by 2, and similarly omega square is minus 1 minus root 3 iota by 2. So in JEE Main you'll find the problems where they will give this complex cube root of unity in different ways. Sometimes they will give that alpha is this complex number minus 1 plus root 3 iota by 2. Sometimes they'll mention that alpha is a root of this quadratic equation. So you should be aware of the fact that if alpha is a root of this equation, then alpha is nothing but imaginary cube root of unity, right? You can take any one of these two values of alpha. You can say either alpha is omega or omega is square. Any one of the two values will work. Here, let us say alpha is omega. For this problem, we are taking alpha as omega. If you want, you can take omega square also. It will have the same effect. Now, regarding omega, we know these two properties, that omega cube is 1, right? We are familiar with these two results, that omega cube is 1, and sum of all the cube roots of unity, that is 1 plus omega square, this is 0. We are familiar with these two results. So here, this is a problem basically on this formula 1. We have to observe that alpha is omega or omega square, and then this property. Now it is given that sum of this series, this is 20, then how many terms we need here, right? K is from 1 to n. So what is the value of n if sum is 20? Now let us try to figure out that if we take different values of k, then what are the terms we are getting here? If I take k as 1, then alpha raised to k means omega. And 1 by alpha raised to k means 1 by omega square of this one. This will become omega, and 1 by omega, that will be omega square, because omega cube is 1. Omega plus omega square will be minus 1, and minus 1 square will become plus 1. So if k is 1, the first term will be 1. Now let us take k as 2. If k is 2, the term will be, we are calculating this one, alpha raised to k plus 1 by alpha raised to k square. So if k is 2, the term will be omega square plus 1 by omega square of that one. Now again, 1 by omega square is nothing but omega, because omega cube is 1. And omega square plus omega will be minus 1. So this will become plus 1. Now remember, in this problem, the most common mistake is to think that every term is 1, and therefore we need 20 terms to make this sum 20. But remember, omega cube is 1. So if I take k as 3, then we'll get omega cube plus 1 by omega cube square of this one. Omega cube is 1, another one square. So this will become 4. So first two terms are 1, but the next term will be 4, right? Whenever k is multiple of 3, then each term will become 1, and therefore 2 square will become 4. And when k is not multiple of 3, then you will get this value 1. So here, basically, uh, if I have to find this sum, if I have to find the number of terms so that sum becomes 20, so first term is 1, second term is 1, and the third term will be 4. Now the same thing will repeat if you take k as 4, 5, and 6. At 4 you will get 1, at 5 you will get 1, and at 6 it will become again 4. Because if I take k as 6, then omega raised to 6, that will be 1. 1 by omega raised to 6, another one, 2 square will be 4. So now we have to see that how many terms are needed to get a sum of 20. So clearly you can see that if I take these three terms, sum will be 6 plus another 6, 12 plus another 6, 18, and we need two more terms, right? Then we can get a sum of 20. If I have to create a sum of 20, then we need these many terms. Now, as you can see that 3 plus another 3, 6 plus 3, 9, and then another two term will make it 20. So therefore, the value of n, this will be 9 plus 2, that is 11. And that should be the correct answer for this problem, right? So this was a problem where, first we have to know that for this equation, the roots are omega and omega square. And therefore, alpha has to be either omega or omega square. And we have this relation that omega cube is 1 and 1 plus omega square is 0. So when you take k as 1 or 2, the term will be 1. But if you take 3, then you will get 4. And whenever k is multiple of 3, you will get 4. Whenever it is not multiple of 3, you will get 1. So therefore, uh, total 11 terms are needed to get a sum of 20. And hence the correct answer for this problem will be 11. If z is a complex number, then we have to find the number of common roots between these two equations. Now, this is a problem from Singhese, and it was asked in JEE Main 2024. And here basically, in order to find number of common roots, first we'll solve this second equation. Right? We'll try to find all the roots of this cubic equation, and then we'll try to see whether those roots are also the root of first equation or not. Also, in order to solve any cubic equation, or in fact any polynomial equation of degree more than 2, whether it is cubic, biquadratic, and so on, one root we need to get using heat and trial method, and then from there we can get the remaining roots. So if I have to solve the second equation, one root we have to find using heat and trial. And for using heat and trial, mean constant term is 1, so we have to check with either plus 1 or minus 1. Right? We need to check only with the factors of constant term. So in place of z, if I substitute minus 1, because z equals to plus 1 will not work, right? We have all the positive, we have all the terms with plus sign in between, so it will not have any positive root. So let us check with z equals to minus 1. In place of z, if we substitute minus 1, the first term will be minus 1 plus 2 minus 2 plus 1. So it will become 0. That means z equals to minus 1 is a root of this cubic equation. And if z minus 1 is a root, this will imply that z plus 1, this will be a factor of this cubic. Right? For a cubic, we can have three linear factors. One of the linear factors will be z plus 1. So now we'll try to split the terms in such a manner that we can create z plus 1 as common factor, so that from there we can get the quadratic factor. So given equation is z cube plus 2z square. Now because we need z plus 1 as factor, so 2z square I'm writing as z square plus another z square. So that from first two terms we can get z plus 1 as common factor. Now again we have z square next term, and if I need z plus 1 as common factor, next term must be z. So that from these two again you can take z plus 1 common, and because we had 2z here, z we can write as z plus 1, this equals to 0. And now you can see that you can take z plus 1 common from all of these three terms, right? We can take z plus 1 common from here, from this one, and from these two terms. If you want, you can divide this cubic by z plus 1 and then get the quadratic factor, but this will be another easier method of finding the quadratic factor. So from first two, you will get z square. From next one, you will get z plus 1 equals to 0. And now clearly you can see that for this equation, if first term is 0, z equals to minus 1, this we have established earlier. And if z square plus z plus 1 is 0, from there you will get the roots as omega and omega square, where omega is the imaginary cube root of unity, omega and omega square. So basically for the second equation, these are the three roots, minus 1, omega and omega square. And now we need to check minus 1 we got from z plus 1 and omega square from this next quadratic equation, z square plus z plus 1 equals to 0. Now we need to check whether these numbers are also the root of first equation or not. So let us check one by one. If I take z as minus 1, then minus 1 raised to odd power, that will be minus 1. Minus 1 raised to even power plus 1 plus 1, right? So we are getting left hand side as 1. So minus 1 will not satisfy, right? Minus 1 cannot be common root because it is not root of first equation. If I take z as omega, let us check with z equals to omega. Remember, omega cube is 1. So if I take z as omega in first equation, the left hand side will be omega raised to 1985 plus omega raised to 100 plus 1. Now, because omega cube is 1, we can divide this by 3. And if I divide this by 3, the remainder will be uh, 5 by 3. So, remainder will be 2. That means this term will become omega square. And next term, omega raised to 100 will be same as omega, because omega raised to 99 will be 1 plus 1. This will be 0. That means omega is a common root between the two equations. Omega is a root of second equation, and it will also satisfy the first equation. Similarly, let us check with z equals to omega square. Now, if omega is a root, omega square, this will also satisfy, because in place of z, if we write omega square, then this term will become omega square raised to 1985. When you divide by 3, the remainder will be 1. So, first term will become omega. And similarly, this term, second term, omega raised to 200, omega square raised to 100. And when you divide by 3, then you will get omega square. 198 is multiple of 3, so this will become omega square plus 1, which is again 0. So as you can see that z equals to omega and omega square, both of these numbers will satisfy the first equation also. So therefore this is also a common root, right? So for second equation there are three roots, minus 1, omega and omega square. The two roots omega and omega square will also satisfy the first equation, and therefore the number of common roots for this system of for these two equations, this will be 2, and hence the correct answer is second option, right? So this was not a difficult problem. Again, just solve the second equation. One root you need to find using heat and trial method, and once you get that root, the other two roots are omega and omega square, and then we need to verify from the first equation. So only the other two roots, omega and omega square, is satisfying the first equation, and therefore those two are the common roots, and hence the correct answer for this problem is second option. Let S1 be the set of complex numbers satisfying this condition that mod z is less than or equal to 5. S2 is another set of complex numbers satisfying this condition that imaginary part of this complex number, this is non-negative, greater than or equal to 0. And then S3 is this set of complex numbers satisfying the condition that real part of z, this is either positive or 0. Then we have to find the area of region bounded by intersection of these three, right? Area of the region S1 intersection S2 intersection S3. So first let us plot these three locus. One is mod z less than equal to 5, another one real part of z positive, and third one imaginary part of this complex number positive. Then we'll see what is the common region in all three, right? What is the intersection of all three of them, so that from there we can identify the area that we have to calculate. So mod z less than equal to 5, that is nothing but a circle with center at origin and radius 5 unit, all the points inside that circle. So the first locus is fairly straightforward. Mod z equals to 5 means points on this circle, either on the mod z means mod z equals to 5 means points on the circle, less than 5 means points inside the circle. So the first inequality will represent all the points which are either inside the circle or on the circle, center at origin, radius 5 unit. Third one is real part of z is positive, right? Third inequality, real part of z is positive. That means we are talking about first or fourth quadrant, right? In first and fourth quadrant, x will be positive. Real part of z positive means x is positive. So we do not have these two quadrants, right? I mean, if I take intersection of S1 and S3, then we have this half of the circle in first and fourth quadrant. But there is one more inequality here, that is imaginary part of this complex number should be positive. So let us try to separate the real and imaginary part, and then we'll see what kind of locus we are getting from here. So imaginary part of this complex number, and also you can see that these two terms are same, 1 minus root 3 iota divided by 1 minus root 3 iota. So we can separate these two. We can write z by 1 minus root 3 iota plus 1. This should be greater than equal to 0, and 1 is a real number, so you can uh, remove this one, because imaginary part of z1 plus z2 is same as imaginary part of z1 plus imaginary part of z2. So now we can write this as imaginary part of z by 1 minus root 3 iota, that should be positive. Z you can write as x plus iota y, because once we have an equation in xy, then we can identify the type of locus. And to separate the real and imaginary part, multiply and divide by the conjugate of this denominator. So this is the inequality that we are getting. And if we talk about the imaginary part of this complex number, imaginary will you will get when you multiply x with root 3 iota, so it will be root 3x and then iota into y plus 1. So root 3x plus y, and that divided by, in denominator you will get 4, right? Minus square plus root 3 iota square. So this is the imaginary part of that complex number, and this should be positive. So finally we are getting this locus root 3x plus y greater than equal to 0. Now this will represent, if I had equality sign here, then it will represent a straight line passing through origin, and the slope of line will be minus root 3. That means if I had equality sign here, then we'll get a straight line passing through origin. This is the equation of line root 3x plus y equals to 0. Now here we have the inequality that this should be greater than 0. That means it will represent any one side of this line. Either it will represent this side of the line or it will represent the other side of the line, right? Now, if I take any point in first quadrant, it will satisfy this inequality, right? If I take points like 2, 3 or 3, 4, any point in first quadrant, then it will always satisfy this inequality. That means this inequality will represent the this side of the line, right? The line in upper side, you can say. So now if I take intersection of all 3 points inside the circle, x is positive, so that means we are talking about right side of y-axis, and then we have upper side of this one, this line. So clearly you can see their intersection will be nothing but this common part. Okay, this shaded region will be the intersection of all 3. It should be on right side of y-axis, so that means we have to neglect the other side. The points should be inside the circle, and also it should be on upper side of this straight line. So this shaded region is the intersection of all 3. Now the question is how to find the area of this shaded region. So for that we need to calculate this angle, right? If I can find this angle theta, then we have standard formula for finding the area of this shaded region. Now remember, for this line, the slope of this line is minus root 3. That means the angle made by this line with x-axis, that will be 120 degree. So if this angle is 120 degree, the other angle will be 60 degree. That means this must be 60 degree. And now we can easily find this angle. This angle is also 60 and this one is 90 degree. So if I talk about the complete angle, it will be 90 plus another 60, that will be 150 degree. So now we can find the area here. Area will be half of, for area the standard formula will be pi r square and then theta by 360. Radius of the circle is 5 units, so pi into 5 square and then 150 divided by 360. Right? If I write in degree, then here the angle is 150 degree and total angle is 360 degree. So this will become 25 pi, and if we divide by 30, then this becomes 5 by 12. So finally this is 125 pi, this divided by 12. So that is option C, and therefore that will be the right answer for this problem. So in this problem, the important concept was to identify the different locus here. First one is straightforward, points inside the circle. Third one, this is also not difficult. X is positive, so first or fourth quadrant. And in order to decode this second one, in place of Z, write x plus iota y. And if you can make this observation that you can separate one, then the calculation will be slightly less. Otherwise, also you will get the same result, but you will have to do some more calculation. So finally, we got this line, and now intersection of all three, that was this shaded region, and area of this region will be pi r square theta by 360. Finally, after calculation, we got option C as correct answer for this problem. Let the complex numbers alpha and 1 by alpha conjugate lies on these two circles respectively. That means alpha is on the first circle, z minus mod z naught square equals to 4, and 1 by alpha conjugate is on second circle. Also, you can see that these two are concentric circle because for both of them, the center is at point z naught, right? So then, and it is given that z naught is 1 plus iota. Then the question is, what is the value of 100 alpha square? 100 into mod alpha square, right? Modulus of alpha square. Now, there are different methods of solving this problem. One approach will be that point alpha lies on first circle. So that will give you one equation in alpha, and z naught is already given. And similarly, 1 by alpha conjugate lies on second circle. And by solving those two equations, you can try to find value of mod alpha. However, there is another interesting approach of solving this problem using geometrical method. So here, if you notice, for these two circles, they have same center. These two are concentric circle. So we are going to plot these two circles, and also for simplicity, I'm drawing the complete circle in first quadrant. However, the actual diagram will be a portion of the circle will be in may not be in first quadrant because center is at 1 plus iota, center is at 1 1, and the radius is 4 unit. Here the radius is 2 unit. But just to explain the idea and to keep the diagram simple, I'm drawing this in first quadrant. So let us say these are the two concentric circle, and this is the center of these two circles at point z naught. Now, before we attempt this problem, there is one important concept that for these two complex numbers, alpha and 1 by alpha conjugate, the argument is same. So this is one important point because 1 by alpha conjugate, this you can multiply and divide by alpha, and then it becomes alpha by mod alpha square. And if you multiply a complex number by some positive number, its argument will not change. So this complex number 1 by alpha conjugate is nothing but alpha by mod alpha square, and mod alpha square is always positive. That means these two complex number will always have same argument. That means they will lie on same straight line passing through origin. Now it is given that alpha lies on the first circle. Alpha lies on this smaller circle. For smaller circle, the radius is 2 unit. This is 2 square, and for the bigger circle, the radius is 4 unit. So on first circle, we have the complex number alpha on the inner circle. So let us say this is some point A representing the complex number alpha, and this is another point B representing the complex number 1 by alpha conjugate. And because these two have same argument, they will lie on the same straight line. Let us say argument of each one of those two is theta. So they will lie, I mean, this point O, A, and B, these three will be collinear on a same straight line. And now using simple geometry in one or two line, you can get the answer for this problem. Let us join the center of the circle with origin and also join the center of the circle with this point B. Let us call this point at some point C and also join this point C and A. Now, if this angle is theta, we are going to use cosine formula, right? We are going to use cosine formula in two triangles. One triangle OAC and the other triangle OBC. In these two triangles, we'll use cosine formula, and from there, in few lines, we can get mod alpha square. Right? Let us say mod alpha is lambda, and also this point was the center of the circle, so this will be 0.11. That means OC, this length is root 2 unit. Radius of inner circle is 2 unit, and the radius of outer circle, this is 4 unit, right? So if I write cos, and let us say that modulus of this complex number mod alpha, this is lambda. Some modulus of this complex number is lambda, and that means modulus of 1 by alpha conjugate, this will be nothing but 1 by lambda. Now if I write cos theta in this triangle OAC, then this thing is lambda. So we'll get lambda square plus root 2 square and minus 2 square, right? And this divided by, I mean, cos theta is, so sum of the square of two adjacent side minus the opposite side square, and this divided by 2 root 2 lambda. This is cos theta in the triangle OAC, right? In triangle OAC, cos theta will be lambda square plus root 2 square minus 2 square, and that divided by 2 root 2 lambda. And now let us find cos theta in this triangle OBC. So in triangle OBC, the length OB will be modulus of this complex number 1 by alpha conjugate. So that is 1 by lambda square plus this other side, this will be 2 unit, root 2 square, so that is 2. And this opposite side, this is 4. So minus 4 square, and this divided by twice of these two adjacent sides. So that means 2 root 2, and this multiplied by 1 by lambda. So this is the relation that we are getting. And now by solving this equation, one can easily get the value of lambda, and lambda will be nothing but mod alpha. So from these two equations, root 2 you can cancel, right? 2 root 2 you can cancel. So then this becomes lambda square minus 2. And on right hand side, you will get, if I multiply this with, I mean, this becomes 2 root 2 lambda. So lambda square we can multiply, and then we have, uh, this will become 2 minus 16. So that is 14. So that means here we'll get 1 minus 14 into lambda square. Right? 2 root 2 will cancel from both sides. And then this right hand side, we'll get 1 lambda and another lambda from here. So we'll have lambda square. So 1 and minus 14 lambda square. So from here you can see that 15 lambda square, this will become 2 plus 1, 3. That means lambda square is 1 by 5. And lambda square is nothing but modulus of alpha square. Right? So lambda square becomes 1 by 5. The question was we need 100 into alpha square. So 100 and alpha square means lambda square, right? Mod alpha square means lambda square. Lambda square was 1 by 5. So this will become 20, right? 100 into 1 by 5. So that should be the correct answer for this problem. So in this problem, basically the important concept is that the argument of these two complex numbers are same. One is alpha, another one is 1 by alpha conjugate. So therefore, if point O, point A and the point B, these three are collinear points. They are on same straight line. Now you have two triangle. One triangle is this triangle OAC. This is one triangle. So find cosine theta in this triangle. And then the other triangle is O, and then you have BC, right? This triangle OBC. Now find cos theta in this triangle, and then by equating those two, we can get the value of lambda square. And once we get lambda square, 100 into alpha square will be 100 into 1 by 5, that is 20. And that is the correct answer for this problem. Let S be the set of complex numbers satisfying these two inequality. One is mod Z minus 3, this is less than or equal to 1. And the other one is Z into 4 plus 3 iota plus Z conjugate into 4 minus 3 iota, and this is less than or equal to 24. Obviously, the first one will represent all the points inside a circle or on the circle with center at 3, 0 and radius 1 unit. And in order to identify the second locus, in place of Z, we'll substitute x plus iota y. If alpha plus iota beta is a point in S which is closest to 4 iota, then we have to find the value of 25 into alpha plus beta. So in this problem, first basically we have to plot the two locus, and then we have to identify the complex number which is uh, in that locus and is at minimum distance from this point 4 iota, right? So let us plot the diagram and then see what kind of locus we are getting here. So let us say this is our imaginary axis and this one is the real axis. The very first locus is mod z minus 3 is less than or equal to 1. If I had equality sign there, then it will represent all the points on a circle with center at 3, 0 and radius 1 unit. But we have less than or equal to sign, so that means we have points either inside the circle or on the circle. Also, the second locus is this one. So in place of z, let us substitute x plus iota y. So we have x plus iota y and this multiplied by 4 plus 3 iota, and z conjugate means x minus iota y and this multiplied by 4 minus 3 iota, and this should be less than or equal to 24. Now see here, right hand side is a real number, so this inequality will make sense only when the left hand side is real. So that means iota term will cancel, right? So let us write the real part only. You will get real part as 4x minus 3y. If you want, you can write the imaginary part also, but it will cancel from the two terms. So, and similarly 4x, and from here you will get minus 3y. This is less than or equal to 24. So from here we are getting this locus that 4x minus 3y, 2 we can take common and then we can cancel. So minus 12 less than or equal to 0. So this is the locus that we are getting, 4x minus 3y minus 12 less than or equal to 0. So this will represent any one side of the line. If I had equality sign here, then it will represent points on the line. Inequality means any one side of the line. Also, for this circle, the center is at 3, 0. And you can see that this is a line passing through point 3, 0. For this line, the slope will be positive. And if I make y 0, x will be 3. If you make x 0, y will be minus 4. So it is a line with positive x-intercept and negative y-intercept. So this is the line that we are getting. Right? If I had equality sign, then it will represent all the points on this line. But because of inequality, it will represent any one side of the line, either this upper side or lower side. Now, if I check with origin, because it is always easy to check with origin. So if I substitute 0, 0, it is satisfying this inequality. Right? 0, 0 will satisfy this inequality. Minus 12 is less than 0. So that means it will represent the upper side of this line. So points inside the circle and also on the upper side of this line. So that means this is the intersection of the two inequality, right? In this shaded region, the point, S is representing all the points in this shaded region. Now, alpha plus iota beta, this is a point in S which is closest to 4 iota. Now 4 iota will be somewhere here. This is point 0, 4, right? This point will be 0, 4. And S is a point in this shaded region, and the distance between these 2 points, let us call this point A, and you have some point P in this shaded region. So the distance between point P and A, that should be minimum. Now we know that minimum or maximum distance of any point from a circle is always along the line joining the center of circle with the given point. That means if I join these 2 points, let us call the center of circle is at B. So if the point P is this one, then the distance AP will be minimum. Again, I'll repeat, point P can be any point in this shaded region. Now we have to find that particular point which is at minimum distance from point A. So if I join point A with the center of circle, and if P is the point of intersection of line joining OB with the circle, then this is the required point, right? This point will be the point of minimum distance. So if this point is alpha beta, the coordinate of P will be alpha beta. Now, there are different ways of finding alpha beta. One, you can write the equation of this line AB, the equation of circle, and then you can then you can find their point of intersection. But another easier method will be that you can use section formula. For the circle, the radius is 1 unit, so this length PB is 1, and also uh, this length AB, that will be root over 3 square plus 4 square, that is 5 unit. So that means AP will be 4 unit. So now P is a point which is dividing AB internally in ratio 4 is to 1. So therefore, if I find alpha here, alpha will become 4 into 3 plus 1 into 0. So that will be 12, and that divided by 4 plus 1, 5. So using section formula, this will be alpha. And similarly, beta will be 4 into 0 plus 1 into 4, and that divided by m plus n, so 4 plus 1, 5. The problem was we need to find 25 into alpha plus beta. So alpha plus beta, that will be 16 by 5, and then 16 into 5, that will be 80. So that is the correct answer for this problem, right? So this was again not difficult problem, just we had to plot the inequalities. First one circle, second one side of the line, and then maximum minimum distance of any point from a circle is always along the line joining that point and the center of circle. So from there we got this point P, and using section formula, this was the coordinate of P. Finally, our answer will be 25 into 16 by 5, that is 80. The number of elements in this set Z, Z is set of all complex numbers of this form A plus iota V, where A and B are integers, and uh, the modulus of this complex number Z minus 3 plus 2 iota, this is between 1 and 4. Now we know that this inequality, this will represent a region between two circles, one of radius 1 unit, another one of radius 4 unit, and the center of the circle will be at point 3 minus 2. So basically we have to find that how many points are there with integral coordinates. Z is a plus iota b, and a and b, these two are integers. So basically we need to figure out the number of points whose x coordinate as well as y coordinate is an integer, and the points lies between these two concentric circle. Now one simple trick, and you can save significant amount of time in calculation. Here, instead of plotting this circle with center at point 3 minus 2, we are going to shift the origin. That means we are going to use shifting of origin, and will make the center of the circle at origin. Right now, for these two circles, the center is at point 3 minus 2. So instead of 3 minus 2, we'll make the center of the two circle at origin, or let us say we'll take this complex number as some other complex number omega. So then it becomes mod omega, the inequality becomes mod omega greater than 1 and less than 4. And now this will represent all the points inside a circle with center at origin and radius, two concentric circle, one with radius 1, other one 4 unit. And because we are shifting the origin by integral coordinates, right? Earlier the center is at 3 minus 2. Now we are making the center at origin. So basically we are shifting center from 3 minus 2 to 0, 0. So both x and y coordinate we are we are shifting by integral coordinates. So therefore, number of points with integral coordinate in this set will not change. So now let us plot these two circles and then try to identify that how many points are there with integral coordinate inside these two circles. So one circle, center at origin and radius 1 unit. So that will be a smaller circle. Let us say this is the first one. And the other one will be a circle with center at same point origin, but the radius is 4 units. So this will be a slightly bigger circle. So let us say this is the second circle. This one is the real part of real axis or the x-axis, and this one is imaginary axis. Now, for the bigger circle, the radius is 4 unit. For a smaller one, the radius is 1 unit. Now, between first we'll count all the points which are inside the bigger circle with integral coordinate, and then we'll remove those points which are not inside the smaller circle, right? This inequality will represent regions between these two circles, outside the inner circle and inside the outer circle. Now, let us draw different lines. This is y equals to 1 line, the next line y equals to 2 line, and another one y equals to 3 line. Y equals to 4 line will be just touching the circle at this point. So there will not be any points with integral coordinate here. And on negative side also, number of points on these, because the figure is symmetric about x. So number of points on y equals to 1 and minus 1 will be same. Number of points with integral coordinate on 2 and minus 2, these two will be same. And similarly, number of points with integral coordinate on the line y equals to 3 and minus 3, these two will be same. This line is y equals to 1 line. This one is y equals to 1. Here we have y equals to 2 and so on. Now, on this line x-axis, the coordinate of this point will be 4, 0 because the radius of bigger circle is 4. This point will be minus 4, 0. So if I talk about this line y equals to 0 or the x-axis, starting from minus 3, 0, minus 2, 0, minus 1, 0, 0, 0, and in this manner up to 3, 0, right? So on this line, starting from minus 3 up to plus 3, total will have 7 points, right? So number of points on this line, here if I write the answer here or count the number of points with integral coordinates. So on y equals to 0 line, we are going to get 7 points. When this point is 4, 0, so just before that one, you'll have 3, 0. Remember, we need points only inside the circle, not on the circle because there is no equality here. So from minus 3, 0 to plus 3, 0, total there will be 7 points. We are not, at a later stage, we'll remove the points which are inside the smaller circle. First, let us count all the points which are inside the bigger circle. So on y equals to 0 line, we have 7 points. Then on y equals to 1 line, remember this outer circle will be x square plus y square, and this equals to 4 square 16. So if y coordinate is 1, the x coordinate will be root 15. So for this point, the coordinate will be root 15 and 1. And similarly on negative side also minus root 15 and 1. Now again, root 15 is a number bigger than 3. So that means 3, 1 will be inside the circle. Minus 3, 1, this is also inside the circle. So minus 3 up to plus 3, including this point 0, 1, total you have 7 points. And same number of points on y equals to minus 1 line. So that means twice of 7 points on y equals to 1 line, another 7 point on y equals to minus 1 line, because the graph is the curves are symmetric about x-axis. Next possibility, if I take y as 2, then x square will become 12, x will be root 12. So x coordinate root 12, y coordinate 12. Now again root 12 is bigger than 3, right? Root 9 will be 3, so root 12 is more than 3. That means 0.32 is inside the circle. And similarly minus 32, that is also inside the circle. So from minus 3 up to plus 3, you'll get another 7 points on this line y equals to 2. And finally this line and on y equals to minus 2 also will have same number of points. On y equals to minus 2, we'll get another 7. So therefore, I have taken 2 outside here. Now, next possibility, if I take y as 3, if y is 3, x will become root 7. Now, root 7 is smaller than 3 and bigger than 2. right? So the point 2, 3 will be inside the circle, point 1, 3 is inside the circle, and so 2, 3 and minus 2, 3, right? This point will be minus 2, 3, minus 1, 3, and so on. So from minus 2 up to plus 2, right? Again, I'll repeat, root 7 is less than 3 and more than 2. So the point just inside the circle will be 2, 3, and on negative side minus 2, 3. So from minus 2 up to plus 2, you'll have 5 points. 5 points on line y equals to 3, another 5 on y equals to minus 3. So these are the number of points with integral coordinates inside the bigger circle. Now we need to remove those points which are not satisfying this condition that modulus is greater than 1. That means the points which are either inside the smaller circle or on the smaller circle. So clearly you can see that there will be 5 such points, right? Those points will be, one will be the origin, and you have other 4 points, 1, 0, 0, 1, minus 1, 0, 0, minus 1. So there are 5 points which are either inside the smaller circle or on the smaller circle, and total we have these many points inside the bigger circle. So the number of points with integral coordinate outside the smaller circle and inside the bigger circle, that will be this number. Now 7, this you can calculate, 7 into 4, so that will be 28 plus 7, 35, plus another 10, 45, minus 5, so that will be 40. So that should be the correct answer for this problem. The right answer for this problem will be 10. And in this question, the important concept was that once you shift the origin by integral number of coordinates, right, instead of minus 3 minus 2, we are making the center of the circle at origin. And that means in place of this complex number, we are writing another complex number omega. So the number of points with integral coordinate will not change, right? And first count, whenever we need number of points with integral coordinate either inside a circle or ellipse, then you just draw a number of parallel lines and count how many lines, how many points are there on y equals to 1 line, 2 line, and so on. So finally we got 45 points inside the bigger circle. 5 points were either on the smaller circle or inside that circle. So our final answer will be 45 minus 5, which is 40, and that should be the correct answer for this problem. A point z moves in complex plane such that argument of z minus 2 by z plus 2, this is pi by 4. Then we have to find the least value of modulus of z minus 9 root 2 minus 2 iota square. Now in this problem, first we have to identify this locus, and because z is a point satisfying this condition, and then we have to figure out that what will be the minimum value of this modulus. Now, before we attempt this problem, there is one important concept that you must know. If I have an equation of this form, argument of z minus z1 and this divided by z minus z2, where z1 and z2 are two fixed complex number and z is a variable complex number. So argument of z minus z1 divided by z minus z2, this equals to theta. Then there are three possibilities. One possibility is that theta is 90 degree. In this case, it will represent a semicircle. Right, this locus, argument of z minus z1 by z minus z2 equals to 90 degree. That will represent a semicircle. Another possibility is that theta is greater than 90 degree and less than 180 degree. So theta is another possibility that theta is an obtuse angle more than 90 degrees. So in that case, the same locus, this will represent a minor arc, and we'll see how to decide how to plot those locus. So this is second possibility, and the third possibility is that theta is between 0 and 90 degree. Theta is an acute angle. So in that case, this locus will represent the major arc of a circle, and the line joining the points z1 and z2, that will be one chord of that circle. For example, if theta is 90 degree, then line joining z1, z2, that will become the diameter of the circle. Theta more than 90, more than 90, then it is major arc. Less than 90 means more than 90, then minor arc. Less than 90 means major arc. And the line joining the point z1, z2, that will become one chord of the circle. So here if I have to plot this locus, argument of z minus 2 and this divided by z plus 2, and this equals to pi by 4. So clearly you can see that this angle is less than 90 degree. That means this locus will represent a major arc for which the line joining point 2, 0 and minus 2, 0, that will be one chord. So now let us try to plot what type of locus we are getting here. First we have to plot these 2 points. First we need to plot point 2, 0 and minus 2, 0. So let us draw the coordinate axis. Let us say this line is y-axis, and similarly this horizontal line, this one is x-axis. So first draw these 2 points, one point 2, 0, another one minus 2, 0, and the line joining these 2 points, this will be the chord of that circle. So there are two possibility of drawing circle here. One possibility is that you can draw a circle like this, and this point A 2, 0, and on another side, let us say this point is A dash minus 2, 0, and it will represent major arc. So that means because the angle is less than 90, it will represent major arc. So it will represent this arc in first and second quadrant. That is one possibility. Another possibility will be that we can draw another circle with AB as chord, but now the major portion of circle is in third and fourth quadrant, and only a portion of the graph is in uh, first and second quadrant. So these are the two possibilities, right? That given locus that will represent any one of these two cases. Either it will represent the major arc in first and second quadrant, or the major arc of the circle in third and fourth quadrant. And the line joining these 2 points, A and A dash, that should be one diameter, one chord of this circle. Now, how to identify that which one is the correct locus? So for that, take any point on this curve. Let us say this is point. Take any point on any one of these two curves. Let us say that is point P. Now join point P with these 2 points A and A dash. So, and next step, make a counterclockwise arrow here. And now the final vector is this PA vector. So that final vector should be in numerator, right? So here you can see that in numerator we have z minus 2, and the vector PA, or rather vector AP, right? That will be position vector of P minus position vector of A. So that will become z minus 2. So therefore this is the correct graph, right? This upper one is the correct graph. This angle will be pi by 4, and uh, when we make the counterclockwise arrow, then this vector PA is in numerator. Also, if you want the equation of this lower part of the curve, if you want the equation of this major arc in third and fourth quadrant, then for this one, the equation will be argument of z plus 2 and this divided by z minus 2. This equals to pi by 4. Because if you take a point somewhere here and then join with A and A dash, make counterclockwise arrow, then the final vector will be z plus 2. Right? If I have a point, let us say this is some point P representing complex number Z. Now join PA and PA dash, and the final vector will be, when you make counterclockwise arrow, the final vector will be PA dash. So that should be in numerator, right? That means in numerator we must have Z minus minus 2, that is Z plus 2. So that will be the equation of this one. Now the question is how to find the center and the radius of this one, and also this is the given point z minus 9 root 2 minus 2 iota. So first let us find the center and radius of this circle. So here basically using geometry you can easily get the center and radius. Let us say this point is the center of the circle. So here because this angle is pi by 4, the angle at center will be pi by 2, and half of that angle, this will be pi by 4. That means this angle is pi by 4. And now this length is 2 unit, OA or OA dash, that is 2 unit, and this angle is pi by 4, this one also pi by 4, so this length will be another 2 unit. That means the center of this circle is at point 0, 2. And this point, as you can see that 9 root 2 and 2, that is also having same y coordinate. That means that point will be somewhere here. This is the point. Let us call this point as some point Q. So this is the point, x coordinate 9 root 2 and y coordinate 2. And for the circle, the radius is 2 root 2, right? Because this length is 2 and this one is another 2. So radius will be 2 root 2 and the center is at point 0, 2. So that means coordinate of this point will be, let us call this point P. So x coordinate will be the radius of this circle, which is 2 root 2, right? This length will be 2 root 2 and the y coordinate is 2. And this thing is nothing but the distance between these 2 points P and Q, right? This length is the distance PQ using this, mod Z1 minus Z2 is distance between points representing the complex numbers Z1 and Z2. So we needed minimum value of that one. And clearly you can see that minimum value will be PQ, right? Minimum and maximum value of any point on a circle is always along the line joining the center of circle with that given point. So P is a point which can move anywhere on this major arc of the circle, and Q is this fixed point. Now if I need minimum value of PQ, then point P has to be here. Point P must be 2 root 2, x coordinate 2 root 2 and y coordinate 2. Now we need minimum value of PQ square. So 9 root 2 minus 2 root 2, that will be 7 root 2 square. 7 square 49 into 2, 98. So that will be the correct answer for this problem. Right, so this was a problem purely on this simple concept that argument of z minus z1 by z minus z2 equals to theta will represent either semicircle or minor arc or major arc depending on the value of theta. In this problem, this is the locus that we are getting, and PQ will be minimum when point P is here. Minimum value of PQ square will be 98, and that is the right answer for this problem. Let the minimum value V naught of this expression V equals to mod z square plus z minus 3 square plus z minus 6 iota square, where z is any complex number. This is attained at z equals to z naught. So the minimum value of this expression is V naught, and this expression we are getting when the value of z is z naught. So then the question is, what should be the value of this expression, right? Modulus of square of modulus of this complex number plus V naught square. Now this is a problem on distance formula in complex plane and one interesting property of triangle. Here if you see this expression mod z square plus z minus 3 square plus z minus 6 iota square. Now we know that if I have mod z minus z1, then this is nothing but distance between the complex numbers, distance between the points representing the complex numbers z1 and z2. So if I talk about mod z minus 3, this will be distance between point 30 and the complex number z. Mod z will be distance of the complex number from the origin. And similarly, this third term, mod z minus 6 iota, this will be distance of point z from the point 0, 6, right? 6 iota will be represented by point 0.06 on y-axis. So basically here, if I take these 3 points, let us say there is one point A representing origin, another point B, and let us say this point is 30, the second term is z minus 3 square, and another point C representing the complex number 6 iota. So the point will be 0, 6. Now let us say P is a point which is representing the complex number Z. So mod Z is nothing but the length PA, right? Mod Z will be PA. Similarly, mod Z minus 3, this will be length PB, and mod Z minus 6 iota, this will be length PC. Now V is nothing but, now you can see that this V will become mod Z is PA, so mod Z square means PA square plus PB square. The second term will be PB square plus PC square. So this is V. Now we know that if we have 3 points A, B, C and P is a point such that PA square plus PB square plus PC square, this is minimum, then that point P is nothing but the centroid of the triangle, right? So that means here V will become minimum if P is the centroid of this triangle, and from there we can get the value of Z naught, right? So these are the 3 vertices A, B, C. So therefore Z naught must be Z1 plus Z2 plus Z3 by 3. That is the standard formula for finding the centroid. So this divided by 3, that will be the centroid Z naught. Now here if you add these three numbers, 0 plus 3 plus 0 divided by 3, so that will give us 1, and uh, 0 plus 0 plus 6 divided by 3, so that will give us 2 iota. So this is the complex number Z naught. Now, this is standard result that you can remember, that PA square plus PB square plus PC square, that is minimum if P is centroid. There is another way of solving this problem also. In place of Z naught, you can write, in place of Z, you can write x plus iota y. And using a square completion method also, you can find the least value of this one. That means in place of Z, if we write x plus iota y, then that given expression V, this will become Z square means x square plus y square. Mod Z minus 3 square means x minus 3 square plus y square. And mod Z minus 6 iota square, so that means x square plus y minus 6 square. This is the expression for V. And now you can make perfect square. I mean, you can take 3 common from x square term, so you will get x square, and from here you will get 2x. For creating perfect square, you can do plus 1 minus 1. And similarly, from y term, you can take again 3 common, so you will get y square minus 12y, but we have taken 3 common, so minus 4y. For creating perfect square, plus 4 minus 4, and plus from here you will get 9, and 9 plus 36, so that will give us 45. So this is the expression for V. And now using a square completion, you can write this as x minus 1 square, first 3 terms, x square minus 2x plus 1. Similarly, 3 times y minus 2 square, and then the constant term will be minus 12 minus 3, so minus 15, 45 minus 15, so that will be 30. So this is the expression for V. Now again you can see that these two terms, they are perfect square, so they will be either positive or 0, right? They cannot be negative because x and y are real numbers. So if this term is always greater than equal to 0, similarly this term is also always non-negative, then clearly you can see that minimum value of this function V, or V naught, this is nothing but 30. And the point where this will become minimum, this is, uh, if I make x minus 1 0, then x will be 1 and y will be 2. So that means Z naught is nothing but 1 plus 2 iota. So using this approach also, you can get the value of Z naught. But if you are familiar with this result, that the point is centroid of the triangle, then directly you can see that Z naught will be 1 plus 2 iota. So now V naught is 30, Z naught is 1 plus 2 iota, and we need to find the value of this expression. Now here in place of Z naught, you can substitute 1 plus 2 iota, and let us call this complex number as some complex number omega. So in place of Z naught, when you substitute 1 plus 2 iota, you will find that omega will become 8 plus 6 iota, right? Replace Z naught with 1 plus 2 iota, because Z naught will be the centroid of the triangle, or using a square completion method, in place of Z naught, we can write 1 plus 2 iota. And after simplification, you will get this complex number omega as 8 plus 6 iota. Now the question is, what is the value of this expression? V naught we have obtained earlier. V naught was 30. And if omega is 8 plus 6 iota, then this is modulus of omega square. So 8 square plus 6 square, that will be 100 plus another 30 square, which will give us 1000. So the correct answer for this problem will be first option. Right, so this was a problem where if you are familiar with this result, that the point will be centroid, then directly you can see Z naught, and from there you can get V naught. Otherwise, in place of Z, you can write x plus iota y, and then you can create perfect square. And perfect squares are never negative. It will be either positive or 0, because x and y are real numbers. So least value of V, that is V naught, that will be 30, and Z naught is 1 plus 2 iota. Substitute the value of Z naught here, and you will find that this complex number omega will be 8 plus 6 iota, and therefore the value of this expression will be 1000, and hence the correct answer for this problem is first option. Let S be set of all complex numbers Z such that this complex number, we have a quadratic expression in Z divided by another quadratic expression in Z, is a purely real complex number. We know that if a complex number is purely real, then imaginary part of that complex number is 0. So S is set of all complex number for which all complex numbers Z for which this quadratic biquadratic complex number is always real. If alpha minus 13 by 11 iota belongs to S or is an element of S, then we need to find the value of 242 alpha square. Now, this is a standard problem where in place of Z, we substitute X plus iota Y. If a complex number is purely real, then imaginary part of that complex number is 0. So by equating the imaginary part to 0, first we try to get expression for, get an equation in X and Y. And if this complex number belongs to S, then in place of X, we can write alpha, and in place of Y, we can write 13 by 11. And from there, we can get the value of alpha or 242 alpha square. But here the problem is that if you directly substitute Z as X plus iota Y, then this will become a complicated expression, right? So here first our aim will be to simplify the expression and then do this substitution. Now as you can see that we have Z square in numerator as well as denominator. If I simply subtract minus 1 from here, then we can get rid of Z square from the numerator. And if any complex number is real, that complex number minus 1 is also a real complex number. So here what we'll do is that because this is a purely real complex number, we can say that imaginary part of this complex number will be 0. And instead of using this complex number, we'll write after subtracting 1 from here because that will get rid of Z square. And because this one is real, that complex number minus 1, that will be also real. So if we subtract minus 1 from there, then you can see that 8 iota Z plus 3 iota Z. So that will give us 11 iota Z. And then minus 15 plus 2, so that will give us minus 13. This will be the numerator part. And that divided by, in denominator, we can have the same expression Z square minus 3 iota Z minus 2, right? And the imaginary part of this complex number will be 0. Now in place of Z, we can substitute X plus iota Y. Still there will be calculation, but it will be slightly less compared to if you directly substitute Z as X plus iota Y. Now in place of Z, if we write X plus iota Y, then we'll get 11 iota Z is X plus iota Y minus 13, and this divided by, in denominator again, in place of Z, we need to write X plus iota Y. So in denominator, we'll get X square minus Y square plus 2xy iota, that will be Z square, minus 3 iota, and Z is X plus iota Y minus 2. This will be the denominator part, and again the imaginary part of this complex number will be 0 because the complex number is purely real. Now in next step, we'll try to separate the real and imaginary part in numerator as well as denominator, so that we can multiply by the conjugate of denominator and get the imaginary part, equate the imaginary part to 0. So in numerator, the real part will be minus, if I take common, then you have 13 plus 11x, in fact plus 11y, right? 11 iota into iota y, and then plus 11 iota x. This will be the numerator part. And in denominator, the real part will be x square minus y square, and then minus 3 iota into iota y. So that will be plus 3y minus 2. This will be the real part of denominator. And plus imaginary part, you will get 2xy minus, from here you will get 3x. So this is the denominator part. Now here what we'll do is that we are going to multiply and divide by the conjugate of denominator. So first term will be this one, and then minus sign in between, and then the second term. So I'm not writing that expression. You can imagine that we have those two expressions here. Whenever we need to separate the real and imaginary part of any complex number, then we have to multiply and divide by the conjugate of denominator. So we are doing that multiplication and equating the imaginary part to 0. In first bracket, you have these terms, and in second bracket, you have this one, right? Now, if I equate the imaginary part to 0, directly you can see that imaginary part you will get when you multiply this real with this imaginary part, as well as when you multiply this iota term with this real part. So here the imaginary part will be 11x into If I multiply 11x with this one, x square minus y square plus 3y plus 2. This is one imaginary part you will get when you multiply 11 iota x with this term. And the second one you will get from here is 13 plus 11y, right? Minus you can keep common. So 13 plus 11y and that multiplied by 2xy minus 3x. This will be the imaginary part of that complex number and this should be 0. Now it is given that uh, this complex number alpha minus 13 by 11 iota, that means the point will be x coordinate alpha and y coordinate minus 13 by 11. That point lies on this curve. So from there we need to get the value of alpha. Now again you can save some time if you directly substitute the value here instead of simplifying, because you can see that this term in place of y, if you write minus 13 by 11, then the second term will become 0, right? So in place of x and y, now substitute those two numbers, you'll get 11 alpha and then we'll have alpha square, y square means 169 by 121 and then 3y, so that means 39 by 11, y is minus 13 by 11 plus 2 and this multiplied by, in place of y, if you write minus 13 by 11, the second term will be 0. So this is the expression that we are getting. We need value of 242 alpha square. Now again alpha is non-zero. It is given that alpha is non-zero. So now this term will be 0. And from here clearly you can very easily get the value of alpha square. If you calculate the value of 242 into alpha square, you will find that that number will be 1680 and that will be the correct answer for this problem. And from here you can get alpha square and then you can multiply that with 242. So this was basically a problem where if you directly substitute z as x plus iota y, then it will make it complicated. So first get rid of this z square by doing minus 1. Then in place of z, write x plus iota y. Because the complex number is purely real, the imaginary part will be 0. And once you have this equation in xy, substitute that given complex number in place of x alpha, in place of y minus 13 by 11. That will make, in place of y, when you substitute minus 13 by 11, this term will become 0 and then you can very easily get the value of alpha square. So in that manner you can save some time in calculation. Finally the correct answer for this problem is 1680. If alpha, beta, gamma and delta, these four are the roots of this biquadratic equation, x raised to 4 plus x cube plus x square plus x plus 1 equals to 0. Then we need to find the value of this quantity. Now this is a problem on nth root of unity. We know that if we have this equation x raised to 5 minus 1 equals to 0. So for this equation the different roots are 1, omega, omega square, omega cube and omega raised to 4, where omega is nothing but e iota 2 pi by 5, because we are talking about fifth root of unity. For nth root of unity, omega is e iota 2 pi by n. For fifth root of unity, omega will be e iota 2 pi by 5. So for this equation, x raised to 5 minus 1 equals to 0. These are the different roots. Now here if you create factors of x raised to 5 minus 1, one factor will be x minus 1 and then other factor will be x raised to 4 plus x cube plus x square plus x plus 1 equals to 0. And as you can see that for this equation x minus 1 equals to 0, the root will be 1, right? When x is 1, x minus 1 will be 0. That means the other four roots, omega, omega square, omega cube and omega raised to 4, they are nothing but the root of this biquadratic equation, right? So basically for this equation, x raised to 4 plus x cube plus x square plus x equals to 1 plus x plus 1 equals to 0. For this equation, the roots are omega, omega square, omega cube and omega raised to 4. So alpha, beta, gamma and delta, they are nothing but omega, omega square and so on, where omega is e iota 2 pi by 5. And now there is one important property of nth root of unity. Let us say if I have fifth root of unity and if I calculate kth power of these roots. That means 1 raised to k plus omega raised to k plus omega square raised to k plus omega cube raised to k, and finally the last term is omega raised to 4. So omega raised to 4 and this raised to k. So for this sum there are two possibility. One, this sum will be 5 if k is some multiple of 5, right? If the exponent is multiple of 5, then this sum will become 5, and this sum is 0 when k is not multiple of 5. And this one is not difficult. This property is not difficult to see, because if we have omega as fifth root of unity, so that means omega raised to 5, this will be nothing but 1, right? Because omega is a root of this equation, x raised to 5 minus 1 equals to 0. So omega raised to 5 will become 1. So whenever k is multiple of 5, all of these terms will become 1, right? Omega raised to 5 will be 1, omega square raised to multiple of 5. If k is, let us say k is 5 or 10 or any multiple of 5, then all of these terms will become 1, and therefore their sum will be 5. And in other cases, if k is not multiple of 5, then this sum will become 1 plus omega square plus omega cube plus omega raised to 4 whenever k is not multiple of 5. One first term will be 1, then these four terms will become omega, omega square, omega cube and omega raised to 4, and sum of nth root of unity is always 0. So therefore we have these two possibilities, right? Now here, if alpha, beta, gamma and delta are the roots of this equation, then it means 1 raised to 2021 plus alpha raised to 2021 plus beta raised to 2021 plus gamma raised to 2021 and plus delta raised to 2021. Using this previous property, you can say that this sum has to be 0, right? If the exponent was multiple of 5, then sum of these 5 terms uh, that must be 5, right? If this exponent was multiple of 5, but clearly 2021 is not multiple of 5, therefore sum of this thing must be 0. Now here the question is, we need sum of this term, right? We do not have 1 here, we need alpha, beta, gamma and delta, sum of these terms raised to 2021. So from this relation, clearly you can see that that sum will become, if I take 1 on other side, this sum will become minus 1, and therefore the correct answer for this problem will be second option, right? So this was uh, an interesting problem from nth root of unity, and it was based on two very simple concepts. One is that for fifth root of unity, these are the factors that you can create, and 1 root x equals to 1, that you will get from here, x minus 1 equals to 0, and remaining 4 roots you will get from here. Also, for nth root of unity, if you calculate sum of kth power of nth root of unity, then that sum will be either n or 0. If I talk about fifth root of unity, that sum will be either 5 or 0. When k is multiple of 5, then this sum will be 5, otherwise it will be 0. Here this number is not multiple of 5, therefore this sum should be 0. And if I take 1 on other side, then we'll get minus 1. So the correct answer for this problem will be second option. For all z belonging to complex number c on the curve c1, which is represented by this equation mod z equals to 4, let the locus of point z plus 1 by z be another curve c2. Then we have to find number of points of intersection between c1 and c2. So basically, the first curve c1 is mod z equals to 4. So this will represent all the points on a circle with center at origin and radius 4 unit. And if z1 is a point on curve c1, then we need to figure out what will be the locus of points z plus 1 by z. That means if z1 lies on curve c1, then we have to find the curve on which all these points z plus 1 by z will lie. So see, if z is a point on this circle, right? If mod z is 4, then we can always take z in Euler's form as, in Euler's form, complex number z is r e iota theta. So we can take z as modulus of z is 4, so 4 into e raised to iota theta. And for different values of theta, we'll get all the points on this circle mod z equals to 4. Now, we need the first locus is obviously straightforward. It is a circle. We need to identify the second locus, and then we need to plot the graph of those two and identify the number of points of intersection. So let us say omega is the complex number, which is representing omega is this complex number z plus 1 by z, right? Now, if I want to find locus of this point omega, then write omega as x plus iota y, and then we have to find some equation in x and y, right? So if omega is z plus iota z, in place of omega we can write x plus iota y, and z plus 1 by z, z is 4 into e raised to iota theta, 1 by z will be 1 by 4 into e raised to minus iota theta, right? Now e iota theta means cos plus iota sine, so this first term will be 4 into cos theta plus iota sine theta, and the second term will be e raised to minus iota theta means cos theta minus iota sine theta. So this is the complex number x plus iota y. Now we know that if two complex numbers are equal, then their real part as well as imaginary parts are equal. That means the real part x, this will be 4 cos plus 1 by 4. So 4 plus 1 by 4, that will be 17 by 4 cos theta. And similarly, if I equate the imaginary part, then y will be 4 sine minus 1 by 4 sine. So that will be 15 by 4 sine theta. Now clearly you can see that this is parametric equation of ellipse. X equals to a cos theta and y equals to b sine theta. And if I need equation of this ellipse, then you can write cos and sine from here and then square and add. So clearly you can see that you will get x square by 17 by 4 square. This will be cos square theta from this first equation. Let us call this equation 1 and 2. So if I need equation of ellipse in Cartesian form, then separate sine and cos and then square and add. So x square by 17 by 4 square, that will be cos square, and sine square will be y square by 15 by 4 square, and sine square plus cos square, that will be 1. So this is the equation of ellipse that we are getting, right? So this is your curve C2, right? Curve C2 is the ellipse, and because A is more than B, this ellipse will have major axis along x-axis. And the second curve C2, this was the first curve C1, this was mod z equals to 4. Mod z equals to 4 means x square plus y square equals to 4 square. Right, in place of z, if you write x plus iota y, then this is the equation that you are getting. So now we have one circle and one ellipse, and we need to identify at how many points these two curves are going to intersect. So let us plot their graph. The circle is x square plus y square equals to 4. So it will have center at origin and radius 4 unit. This is our x-axis and this one is y-axis. So this is the circle that we are getting. Now for ellipse, you can see that for circle radius is 4 unit, and for ellipse the vertex is at 17 by 4. So it will be passing through this point, right? That will be one point on major axis of the ellipse, one vertex. And this number 15 by 4, this is the point where it will touch, it will intersect y-axis, right? When x is 0, y will be 15 by 4, which is less than 4. So the ellipse is passing through these 2 points, right? Ellipse, the graph of that ellipse will be something like this, right? This is the ellipse that we are getting. And as you can see that these two curves are intersecting at 4 points. The question was that at how many points these two curves will intersect. So clearly these two are intersecting at 4 distinct points, and therefore the number of points of intersection between C1 and C2, that will be 4, and hence the correct answer for this problem is first option, right? So this was you can say an interesting problem where first we had to identify the locus of this point z plus 1 by z, where z is a point on curve C1. So in order to identify that locus, let us say z plus 1 by z is omega. Replace omega with x plus iota y, and then by equating the real and imaginary part, we got these two equations. Now these are parametric equation of ellipse, and in order to get the equation of ellipse, you can square and add these two equations, find sine and cos theta, and then square and add. Finally, we are getting 4 point of intersection between these two curves, and therefore the correct answer for this problem will be first option.